Thank you so much. It's a pleasure and honor being here, and hope you've all been learning a lot from the sessions at this conference so far. My name is Ted Wei, and I'm a program manager on the Applied AI team here at Microsoft. Our team builds AI models for apps such as supply chain insights. And I call today's panel, Finally, a good supply chain disruption, AI in supply chain, because I'm sure you all have had your supply chain disruption stories. Maybe you tried to buy a car in the last year and you had to wait months before it was delivered. Maybe your company shipped a product late because of a supply chain dependency. Or maybe you had to go to Costco 30 minutes before it opened and stand in the cold Seattle rain just so you could get lucky and actually buy some toilet paper. And don't ask me how I know that. But what I do know is that there are very smart people out there who are experts in the supply chain and AI space. And today I'm excited that our panel will share with us what that supply chain landscape is today, how AI can disrupt this, and how you as data scientists would be able to think about if you want to get into this field. So let's just start with a quick round of introductions for each panelist. If you could please share a little bit about your supply chain and AI background. And let's start with Ajay.
Great, thank you, Ted. Pleasure to be here, and appreciate you letting me join the Microsoft party here. I am a research director at the Palo Alto Research Center, PARC. We're a Xerox company here in Silicon Valley, and I oversee a portfolio of AI and IoT, where we have a number of R&D initiatives targeting key supply chain elements, which, as Ted just pointed out, is obviously a very hot button topic right now. I've been at PARC for 11 years, and I've been leading teams that have been developing some very exciting technologies around embedded sensing, anomaly detection, predictive analytics, health monitoring, and adaptive optimization. All of these, of course, are very relevant and right at the heart of supply chain analytics.
Great, wonderful. So glad to have you here. Let's go next to Anand.
Hi, good afternoon, everyone. And Ajay, we are very honored and happy to have you on the panel. I'm really thankful that you could join. I've been doing AI, big data, AI analytics for a very long time, across multiple companies. But for the last year and a half, I worked specifically in supply chain. We actually launched a preview product, from Microsoft around the area of helping businesses understand and mitigate disruptions. And in that process, we learned a lot about how AI can really make a big difference in kind of moving the ball forward. So I was on the product management side of that product for some time. And now recently I changed roles and I actually became an AI architect, but staying very close to the supply chain space, among other things, and still kind of finding some really good places to kind of connect the dots and really bring AI to life, so to speak. And Ted and Danny are my colleagues. So really happy to be here with you. Thank you.
Yeah, we're friends of Anand, and now we're friends with Ajay. So thank you so much. Danny.
Yeah, thanks, Ted. Hello, everyone. Danny Godbett, principal data scientist here in the Microsoft Dynamics team in supply chain insights. Before Microsoft, I spent 10 years in the automotive industry as first as an engineer, dealing with vendors going out of business or their factories catching on fire. So I had some of the scars. And later becoming a data scientist, still working in the automotive space, working on optimization of our distribution centers, our factories, working with finance, sales, and marketing. A few years ago, I came to Microsoft, working outside of supply chain, but it's really a domain that's near and dear to my heart. And so a little while ago, I came into this supply chain insights team, really just looking to get back into the domain. So really fascinating space, I think, for data scientists, and really excited to talk about it today.
Well, yeah, it's so great to have all of you as experts in this field. I come from a background of computer vision, so I don't have the supply chain expertise, and that's why you're all here, so that we can learn from you today. And so let me just start with the first question for Danny, and let's just kick it off. And if you could just kind of level set and help explain what supply chain even means. I feel like it's kind of like Bitcoin and blockchain. It's something we think we know, but if we really dig into it, we realize we don't really appreciate the complexity of it. So maybe if you can just level set and just help us define what we're even talking about when it comes to supply chain.
Yeah. So we had a couple of visuals to kind of help tell this story today. But I think you're right on that. It's sort of vague, and I think depending on who you talk to, you'll get different definitions. So I'll kind of stick to the most Wikipedia adjacent definition of a supply chain, but again, it really depends who you're talking to and what all they consider to be part of the supply chain. I think a big part of that vagueness just comes from the fact that in its most sort of generic sense, supply chain is really how businesses flow material and work into value for their customers, whether that's services or end products that they're delivering. And you can really think of that definition defining almost every aspect of the company, even down to like your HR and how you manage your workforce, your manufacturing, your procurement, et cetera. So all of those things really funnel into how does your company best produce value for its customers. But I think to kind of step back from that and maybe try to focus it a little bit more, on the screen, I'm showing kind of a basic diagram of, imagine, you want to buy a loaf of bread. And so at the end point here of this particular very simplistic supply chain, we have a shop. And so that shop, in order to be able to sell you a loaf of bread, has to procure that bread from somewhere. And so these middle nodes in the middle here for production and warehousing could represent a baker, right? You buy bread from, let's say, Franz or Wonder Bread. This can kind of represent them. And then they're obviously getting their raw materials from vendors. And so that could include farms, for example, providing them with wheat and grains. And you can extend this back. Again, this is very simplistic, but that farm has its own supply chain. They need to get seeds from somewhere. They need to get water. They need equipment, et cetera. And so these chains can continue to extend back further and further. And finally, all of this is kind of wrapped together with these little icons in the middle, is that kind of multimodal transportation network that stitches all of this together. We can kind of up-level this and kind of generalize it and look at each of these as kind of a black box that produces that produces according to demand and given a supply of materials coming in. The other kind of facet of this that I wanted to touch on for the audience today, especially the data scientists, is in this domain is I'm always fascinated by the range of granularity that you can deal with. And so I'll kind of go right to left, but it can be as granular as looking at telemetry signals coming off individual machines in a warehouse. I've had projects where we had to map out, where every bolt was in a distribution center to look at how we optimize picking routes. But on the other hand, we can have really high level problems like where do we put a new distribution center, out of, let's say, 10 candidate cities, where do we put that new distribution center? Obviously for that, we don't need to model down to every bolt in the warehouse. It's a much more aggregated kind of problem. And so we need to have that flexibility to kind of right size the granularity to the specific question that we're trying to answer. And then finally, kind of tying it all back to Anand had a great talk earlier where he showed this diagram, but this kind of, it starts to explode that caricature that I had at the beginning, and we start to see like all the actors that are in this supply chain, and these vendors, for example, there can be hundreds of vendors and they can have hundreds of vendors themselves. So the dimensionality is really huge. And you think about, to land that loaf of bread on your table, the sort of the choreography that has to happen here, that all of these people need to orchestrate contracts and move materials to the right places at the right time. And I think it's kind of one of those things where when you start to see the complexity, it sort of becomes like miraculous, right? That anything gets produced. And so it's really like this very deeply complex, relationship-rich domain that we'll be kind of covering today.
Great, great. Thanks so much, Danny. Just really great overview. And I think just helping us appreciate the complexity behind it. And so the next question for Ajay, in light of all of this, maybe you can help paint a picture of what are some areas in supply chain that are ripe for disruption, and what are some of the technologies, especially like the work that you're doing in IoT, that are being brought to bear on all of this?
Sure, Ted. Yeah, as you pointed out earlier, and as Danny very nicely introduced, supply chain has been something we've taken for granted traditionally, and it's only with the recent shocks largely brought on by the pandemic that we've started noticing the issues, and a lot of these have come to the spotlight, right? So obviously, I think at this point, everybody's read about how interconnected everything is. Danny's visual was spot on in terms of the complexity and the different players and stakeholders and their geographical spread. So, there's a number of points where things can get vulnerable. It just takes one shock at one location that may not necessarily immediately impact the other players for the entire system to go into chaos. And so I think what has come to the fore is the need for more granular information, and not just information at each of the stakeholder levels, but also something that can be shared across the network, because everybody's in it together, right? Oftentimes the planning for a lot of these goods, whether they're automotive, whether they're aerospace, whether they're medical supplies, they start many months in advance. They make demand models, they have things planned in factories, there's a lag period there in production, and then there's the shipping, which often from factories in Asia can take months. So there's a lot of little nuts and bolts which have traditionally been protected silos, and people are beginning to appreciate the need for information sharing while still preserving each of the individual players' proprietary information. So there's definitely a big opportunity for better state awareness across the system while still preserving those individual stakeholders' proprietary information. The second piece is being able to predict, and it is kind of a unique set of analytics that need to come into play here as that information becomes more available across the supply chain, because it's not necessarily just matching the patterns to a prior event, because there can be all these shock events that have never been experienced. So you really do need kind of a first principle approach, which Anand and Mayank presented very eloquently in their talk on the digital twin and how that can be an enabler. And last but not least is the need for factoring in sustainability in all of this, right? So traditionally, people have focused on efficiency and cost, and sustainability is increasingly coming into the picture, and not just, again, at the individual stakeholder level, but across the entire supply chain. So I think those are the top three areas I see as being ripe for disruption here.
Great, thanks, Ajay. Yeah, I think it's just, in terms of the interconnectedness of everything, the data that's being collected, and as you called out, just the sustainability aspect of things, right? That's just becoming very much top of mind for all of that. Yeah, thank you. And Anand, I'd love to hear from your perspective, what other areas do you see that are ripe for disruption, and from the software space, what's kind of being applied to these problems?
Yeah. I would like to riff a little bit on what just Ajay just said and kind of take it from there, because he really kind of gave a really good kind of like overview of what the main problems are, right, or the main challenges are. So need to have holistic view of the data, need to have the proper granularity, showing all the interconnectedness. And then of course, like there are some imperatives that are things like resilience and sustainability, obviously. So these are the business goals that we want to achieve. Let's put it like that. From a software perspective, I think the two big areas where there is a real desperate need, I feel, for like huge software companies to step in and really kind of take software of supply chain to a completely different new level. So those two needs are the following. There are two needs. One is that, each player in the supply chain can kind of pretend, if they want to, that rest of the world, everybody that fan in and fan out too, you can pretend that all that is like an external world, and treat everything that happens as essentially randomness, or I don't want to call it noise, but it's like something that nature does to you and you just react to it. They could take that point of view, but that is a highly or suboptimal and highly dangerous way to act. So you need to, even though you are a small cog in a big machine, you need to know what's going on in the big machine. So knowledge of what's going on is very important. So how to get that knowledge, that is a problem that supply chain software has to solve. And that involves like bringing in data from business partners, through kind of mutually beneficial data sharing arrangements, bringing data from the web, bringing data from social networks, bringing data from sensing. We talked about that in the morning a little bit. So getting all these different kinds of data staged and brought into the system, and whatever that modeling framework is, I prefer the digital twin, but even if you don't agree on the framework itself of modeling, you have to agree that whatever framework you use, you need to stage all this data in there, right? So the software capabilities to reach out, to connect to different sources of information and bring it all in and stage it semantically, so that you can kind of get deeper, decoupled from the sources of information and talk about the information itself and ask questions about what is happening where, when, why, rather than having to worry about where did this information come from, what API did it call, and that kind of thing, right? So that's one problem to solve. And then the other big problem, which kind of a dual of this first problem, is that once you have visibility into what the rest of the supply chain is doing around you, you cannot just take actions locally. You have to actually take actions in a way that in some sense you at least anticipate what will happen with the rest of the system, but more importantly and more interestingly, in my opinion, coordinate and even co-optimize, at least with your nearest neighbors, right, in that graph. Even if you don't like co-optimize for the whole network, you can at least like directly talk to your business partners and say, hey, let's kind of do something clever here. Let's try to kind of co-optimize. And this is where AI could really jump in and say, what if contingency analysis and things like that, which we discussed in the morning, this could be a great way to convince a set of people that, hey, what if we together take this set of actions? Look, our joint KPIs, all of them will go up. What if we did this, And so AI can literally be the method to convince people that, hey, we can collaboratively take decisions and actually get better together and make the supply chain robust for everyone. And the AI is giving you the conviction and the confidence that that route or that approach is going to work. So just to summarize, getting global visibility and then taking globally optimal decisions are like the two places where you really need a new kind of software paradigm almost to do this, because it's what we have today is just not working. I'll say that's my frank opinion. It's just we are just in reactive mode right now in many ways. And I would love to hear the other panelists give their point of view also on this. Thanks.
Yeah, and I loved how you riffed on what Jay was saying, and others, please feel free to jump in, and folks on the call too. If you have any questions, please feel free to just pop them in the chat, and we'd love to hear just kind of what's top of mind for you. So in terms of, thank you, Ajay and Anand, just for painting that picture, right? As we talk about visibility, as we do things like what if analysis or the predictability and just how things are not where we want them to be, right? And as you're both describing kind of this world, I'm sure all the data scientists who are listening on this call are like, okay, let's talk about the AI that might be applied to this. So maybe I'll turn it over to Danny. For folks like me, I come from a computer vision background. I'm used to images. I'm used to a certain set of data. Tell us about what's different about supply chain data. If we were to, what kind of AI capabilities and techniques would one need to be familiar with when it comes to working with supply chain data?
Yeah, I think, before we even entertain like the AI that we can use, there's a huge base data problem there that I think both Anand and Ajay kind of talked to, that so within a business, we're going to have some data that might be, let's say, in SAP or in an Oracle or PeopleSoft system. Some of that might be in something like a mainframe that's much harder to access. There's a tremendous amount of the business that's run using spreadsheets or PowerPoints. And all of those are kind of different repositories of data in a sense. And then more broadly, as we start to kind of think about co-optimizing with partners, if we're an SAP shop, they might be a PeopleSoft or an Oracle shop. And so we have these really challenging kind of data integration issues. So I think one of the most foundational things is really what's our kind of data governance and data quality strategy for how we bring all of this data together. But once we're kind of over that initial hurdle, I think there's definitely a special flavor to supply chain and I'm a big fan of crisp DM, but I think most data science processes, right, it always starts with building business understanding. And so I think as a data scientist looking to get into supply chain, it's really important to start there. And a couple interesting patterns that I've seen over the years is, oftentimes in data science, like we're trying to get super precise, really accurate, right? Like minimize your R squared on a regression and that sort of thing. And often in supply chain, again, because of kind of the complexity, sometimes predictability is more important than absolute accuracy, right? And so if you're, for example, trying to set a production plan for a factory, you might say produce 100 units today, 300 tomorrow, 150 the following day. And that's not going to fly. You can't hire and fire people every morning according to to your production plans. And so I think that's always been an interesting takeaway, is that sometimes the absolute optimal solution is not necessarily what's best for the business. And so it's really important that you align your validation and how you structure the problem to those business KPIs and really understand how the business operates. And in an ideal world, right, you can directly correlate your R squared, AUC, whatever metrics you're tracking to dollars or carbon footprint, right, to those business metrics. And then I think Ajay mentioned that, supply chain is all about these sort of like black swan events that, we don't have 100 samples of a vendor catching on fire or of like power being cut off to our factory. And so when we're thinking about building AI, these sorts of like classical ML structures where we can just add a lot of historical training data and get good results, oftentimes it won't work out that way. And so simulation and optimization play a really big role in the toolkit that's needed here. And the combination of those two with ML sort of starts to take us into the reinforcement learning domain. So yeah, I think from the AI side, that's kind of the unique flavor that I've seen in supply chain is certainly that more, I would say, rather than predicting based on historical patterns, it's how do we become more proactive in our optimization and like simulation capabilities to be able to respond as optimally as possible to really big and surprising events.
Yeah, this is cool. Thanks, Danny. Because I think, for us, we kind of think of the AI hammer, everything as a nail, right? But I think there's a really interesting intersection from an AI perspective, the optimization space. You hear a lot about like the quantum folks and those things that they're doing around optimization, a lot of really interesting intersections of how all of this can come together. Ajay and Anand, any thoughts there on just kind of what it looks like from a data scientist perspective in this space?
Sure, I can chime in, and Anand, please free to add at any point. I think the point about the data is such an important one, right? So we talk about wanting more data, but we have to keep a few points in mind with respect to supply chain that make data, even just the basic step of gathering data, so challenging. Just take a single element of the supply chain, a factory, trying to get data sets from a factory. There's so many challenges involved in just that one element of the supply chain. There are so many different players in those factories. They might be concerned, forget about sharing it outside, but just within the factory, the workers are clearly about adding sensors because they think it's tracking their individual productivity, which is really not the goal here. They're not trying to find the slackers in the factory or anything like that. So that can be a challenge. Just the very first step of gathering the data, and then the common data formats. Even like I said, even within a single factory, I've seen all kinds of nuances with noisy data, labeling issues, etc. So just that first step of the data gathering and wrangling can be such a challenge. And then I think, like you alluded with the initiatives like the one that was announced by the White House earlier this week, that's a great step towards progress in that direction. But a lot more needs to be done to come standardized data formats before you can even start thinking about applying AI. The second piece, as Anand touched on, is probably different types of AI technologies will need to be invented to get a good handle on these types of complex data sets coming from just elements of the supply chain distributed globally. Conventional AI works great when you have huge amounts of historical data sets, but when you have such sparse data that's distributed across so many different contexts and locations, it's going to be much harder to pull those classical approaches. And so I think mingling of different disciplines across these elements will be key to get this kind of new AI in place. I think last but not least is some elements of privacy preserving analytics that needs to come into play so that everybody's assured that the data is being used for the bigger good rather than tracking individuals to find slackers, for example. I can't tell you how many times I've had to overcome that inertia for some very much simpler goals in analytics, let alone the much bigger goal of supply chain analytics. So the more people get assurances of the privacy being preserved as all this data is being collected and analytics is being done, I think that's the better chance we have of getting a handle on this problem.
Yeah, this is great. Yeah, thanks. And I think just from, like you mentioned, like the data that's collected and what that used for, right? Yeah. Anand, did you have something to add?
Yeah. No, again, this is such a rich discussion. And so we could literally go on for hours if we get some coffee and, but yeah, there are 2 points I do really want to make. One is around this marriage of AI and OR that needs to happen. It's already happening, right? So what is AI? AI, I'm saying, if I just boil it down, and I'm taking a slightly naive approach here, so forgive me, folks. But just to kind of make it very simple, AI is basically the ability to predict from learned patterns, right? You see a lot of examples of input, output, and ultimately to say, if this input happens, this is what I expect to happen. It's a prediction problem in that sense. OR is saying that OR is more about optimizing. Like I have a bunch of control actions. What is the right setting of the configuration of those control actions? There are many levers in my hand to achieve the best outcome. But when you bring AI and OR together, it's like you are in a kind of interesting way. You're instead of optimizing the plan, you're predicting the plan, the best plan. So you learn. So the idea is that the AI part is kind of sits as a loop inside the OR, and you are actually ranking. You're over time you start predicting what a particular configuration will do, without having to do a full-scale evaluation of its optimality. And this becomes very powerful because now the reason why this is important is because now you can explore a much bigger space of alternatives because there's a mechanical checker in the middle, right, which can predict rather than doing the whole hard work. It can predict that this line is probably not going to be built, not going to be useful, this configuration. And that allows you to explore a much bigger space of the parameter space, right, much bigger volume. And so this marriage of AI and OR becomes very important, right? And then the second one is this notion of, I think you mentioned it, or earlier somebody mentioned reinforcement learning, right? So one of the classic ways of like exploring the parameter space in almost like an automatic or autonomous way is to just use a reward and just let the system guide itself around, and it kind of investigate the space based on reward. Wherever the reward is good, it kind of keeps going in that direction, right? But the problem with that is that you can't really do that in an area like supply chain, because you cannot, in traditional reinforcement learning, you're actually playing with the environment, either the simulation of the environment or the environment itself, right? So you are like playing the game with the environment essentially. So every action you take or every upgrade you do of your action policy impacts the real world. Now you cannot do that in supply chain. I'm saying if your initial starting point is bad, for the long time, your proposals are going to be pretty abysmally bad, and the business will go out of business by the time you learn your optimal policy, right? So you need to have the ability to kind of learn without touching that system. It's called like non-destructive learning. And there is a way of doing this, and Google and some others have really done some good work on this, where there's this notion of offline RL, offline reinforcement learning. And the concept there is that you can watch other players playing. You can just watch. You're not going to actually play. You're not going to make any moves, but you can watch them playing and you can learn to play chess too. So other players are playing chess and you can learn to play chess too, or things like that. And so you can collect offline data of a lot of other players and you can learn from it. And that is non-destructive. So you still have a human in the loop to finally approve the policy that is proposed by the machine. But the act of proposal comes purely in almost like an observational way of learning. But it's reinforcement. It's still reinforcement learning, classic RL, but it's formulated in a slightly different way, not like a continuous training, like inline training. So these two ideas, like the marriage of AI and OR, and then doing some of the exploration of the parameter space through reinforcement, but this new flavor of reinforcement called offline RL. I think these are the two big, like on the horizon, I'm seeing that as the two big breakthroughs that will actually really help solve this problem, in particular for supply chain. Obviously, they have wider applications even beyond supply chain, and that is also equally important.
Great. Thank you so much. This is great. I think especially for folks from a data science background, as they're thinking about, what is it about this? We talk about like the data and how it's structured, and I can imagine a lot of it's all graph-based, all these graph-based techniques. We talked about reinforcement learning and how AI and OR coming together. And I didn't realize we would get into, this non-destructive learning, right? I didn't realize we're going to be like, watching Twitch and watching other people play video games, and we're going to be learning from them, as we think about how to create that optimum policy. But I think these are all great avenues to explore. I think we're at time now. This is such a really exciting discussion, and thank you so much.